All right, Unit 13 for your exam review. This is a longer video. There's a lot of questions. Let's start with reviewing some exponent rules. This is evaluate or simplify. Here, when I have a number raised to a rational exponent that's like a fraction exponent, think about this as a root to start. So what you really have here is going to be the fifth root of 1 over 32. And then once you get that number, raise it to the negative second power. Now the fifth root breaks up over the fraction. So you have the fifth root of 1 over the fifth root of 32. And again, all raised to the negative second power. Well, the fifth root of 1 is just 1. The fifth root of 32 is 2 to the negative second. When I multiply both of these, when I distribute the exponent of negative 2 to both, I'll have 1 to the negative 2 over 2 to the negative 2. Because I have negative exponents, I need to move locations in the fraction. So I'll have 2 squared becomes positive when you move it over 1 squared. 2 squared is 4 over 1, which equals 4. That's the value for number 1. All right, number 2 here. Distribute the exponent. Deal with the negatives later. Distribute and multiply by negative 8. So a to the 1/4 times 8, they're both negative, so it'll be a positive when you multiply them, is going to be 2. And b, 3 over 2 times negative 8 would be negative 24 over 2, which is negative 12. The b is negative, so it needs to move to the denominator of our fraction to become a positive exponent, and the a stays put. So a squared over b to the 12th. Number 3, I'm multiplying. So I'm going to start by multiplying the numbers, the coefficients. 7 and negative 3 is negative 21. I'm going to leave the x's and stuff alone for a second. I'll move those in a minute. I'm going to deal with the numbers here. 6 times 4 is 24. Y squared x to the negative fifth. Now, when I have negative exponents, I'm going to move them, right? I don't want to have the negative exponents. I want to switch them to the opposite part of the fraction. So I'll have negative 21. This x to the fifth in the denominator is going to move up to the numerator. So it'll be positive x to the fifth. And the x to the third there is going to go down to the denominator so that it becomes positive. The y's are already positive, so they're going to stay put. Now we simplify. Well, negative 21 over 24. 3 goes into both of those, so it'll be negative 7 over 8. Now, because they're all positive, now I can subtract. 5 minus 3 is x squared. Because the numerator has a higher exponent, the x squared is going to stay in the numerator. And then the same thing for the last one. 5 minus 2 is 3. The numerator is also bigger, so it's going to stay y cubed on the top. And that'll be your answer. All right, the last one here. I'm actually going to rewrite this down below a little bit. So we'll do number 4 down here. I have n to the third, all right, that has a lot to it. Let's work on this. Start by noticing that you're dividing two fractions. So in order to simplify two fractions that are being divided, you guys use the expression keep, change, flip. Keep the first one, n to the third over p to the fifth. Change the sign to multiplication, flip the second fraction. So n squared is in the denominator. I'm going to do this in one step here. Change that to p to the third times q to the sixth. Now you can subtract and simplify because it's all being multiplied together. If I have m to the first here, 1 minus 2 is negative 1. But here's another way to think about it. I have 1 here, I have 2 on the bottom, so that n to the second becomes n to the first. When I deal with the n's, n to the third is bigger than n to the second. I can cancel off the 2 on the bottom. That leaves me with 1 n in the numerator. Okay, so I'll make this a little easier for you. I kept the m to the first in the denominator. I kept the n in the numerator. For my p's, the 5 on the denominator is bigger. So I cross off the p to the third, That becomes squared. I canceled 3 of them away, so I still have a p squared in the denominator. And then the q, there's nothing to cancel with, so it's going to stay q to the 6. That would be your answer. Now, yes, there are other ways to go about that problem. That's just the way that I wanted to explain. All right, now let's talk about rational exponents some more and some roots. Write the following in radical form. All right, so x to the 3/4. Remember, the denominator of the fractional exponent is the root. So this becomes the 4th root of x, and raise that to the 3rd, the numerator. Now, the other way you can write this is the 4th root of x to the 3rd. Either one of those are equivalent and the same. Number 6, be careful here. We're only taking x to the -1/2, not the 25. It's different than number 7. So what I have here is 25. Now, because it's negative, I move the x to the 1/2 to the denominator, and you rewrite that as a root. The 1/2 power is the same as the square root of x. Now, you can leave that as your answer. I'm okay with that for this. Technically, we don't like radicals in the denominator, so you could rationalize this by multiplying by radical x over radical x. You don't have to here. I'm just showing you that you can. You would multiply straight across and get 25 radical x over x. That's the second answer that's on your solution sheet. 7 is similar. So this time I have the whole quantity, 25x raised to the -1/2. So that would be 25 to the -1/2 times x to the -1/2. Because they're both negative, they go to the denominator of my fraction, which would be 1 over the square root of 25, which is 5 square root of x. Now, just like the last problem, that's acceptable. If you really wanted to rationalize the denominator, you have to multiply by radical x over radical x, which should give you radical x in the numerator over 5x. That's the other answer that's equivalent. The first one is fine with me. Let's simplify some rational expressions. Number 8. First of all, we're just simplifying. There's no adding, there's no subtracting, so before you cannot just cancel the x's. Don't do that. Don't be that person. Let's factor first. You cannot cross things off unless they are in factor form. Don't commit the algebraic atrocity. Factoring the numerator is difference of squares. X plus 4, x minus 4. The denominator factors as a trinomial. Two numbers that multiply to -20 and add to 1 are 5, x plus 5, and x minus 4. Now you are allowed to cancel x minus 4 and x minus 4. Your final answer is x plus 4 over x plus 5. That's it for the first one. Number 9 here. Again, we're not adding or subtracting fractions. We just have to factor. You cannot cancel until you factor. So the numerator, 35 and 20, have 5 that goes into both of them. They both have 1x and 1y. When I divide those out, I'll be left with 7x minus 4y. Well, if you look at the denominator, that actually is equal to the denominator. So I can cancel the denominator with one of the numerator factors, and all you're left with is 5xy. All right, those are the super simple ones. Factor, cancel. Number 10, I'm adding fractions. In order to add a fraction, you need a common denominator. Here in these problems, in order to find the common denominator, I want you to factor, and then we'll figure out what we need. The left denominator is x plus 5, x minus 5. The right denominator is 2 times x plus 5. Now, when I find my common denominator, I need a little bit that's in common from both. Notice that they both have an x plus 5. So I'm going to have x plus 5 in my common denominator. The fraction on the left also has an x minus 5, so I have to include x minus 5 in my common denominator. The fraction on the right has a 2, so I need to include 2 in my common denominator. Now, it looks like the left fraction doesn't have the 2 part, so I'm going to multiply the left fraction by 2 over 2. The right fraction is missing the x minus 5, so I'm going to multiply by x minus 5 over x minus 5. The denominator I already wrote. That's what's going to happen when you multiply by the 2 and the x minus 5. The numerator here, let's take this a step at a time. We're going to have 2 times 5, which is 10. Now the next part I'm not going to write so quickly. I'm going to write it like this. 3 times x minus 5. It does not hurt to write a little bit extra here to make sure you're doing it correctly. I'm going to distribute the 3, which will give me 3x minus 15. So if I combine like terms, 10 minus 15 is negative 5, and we have the 3x minus 5 over my denominator. All right, do not cross off these negative 5s. You are not allowed to do that. You decide, can I factor the numerator? I can't, so this is the fully simplified answer. Right? In order to add, you need a common denominator. In order to subtract fractions, you need a common denominator. So again, you start to find the common denominator by first factoring. I notice that I have an x in both, which is good. So I'm going to have an x as part of my common denominator. The right guy also has an x minus 7, so that also needs to be part of my common denominator. X times x minus 7 is already the denominator of the right fraction, so the left fraction needs to catch up and get an x minus 7. I'm going to multiply there. 2 times x minus 7, and then the minus 3 didn't change. So I'm going to distribute the 2. That'll give me 2x minus 14 minus 3 over our denominator. And then you can combine like terms. 2x minus 17 over x minus 7. Just like the last problem, do not be the person and cross off those x's. You are not allowed to do that. The numerator does not factor, so this is as simplified as you get. All right, next page, number 12. We have 4 more problems here. We are dividing. That's a division symbol. It's a little blurry on the video. In order to divide, you do your keep, change, flip. I'm going to keep the first fraction, and I'm going to factor as I go. Nothing here in the first fraction factors. Change the sign to multiplication. Flip the second one. So the denominator here factors. I need 2 numbers that multiply to 3 and add to 4. That'll be 3 and 1. A plus 3, a plus 1. The numerator becomes the denominator, and a pulls out, and you have a plus 1. Now, since it's multiplication, I don't need a common denominator. I can go ahead and just cancel the like factors. So I should see the a plus 3s can cancel, the a plus 1s, and then the a's. I have a to the first here. That's 1a goes away, which makes that a squared. That's the only thing left. That's your final answer. Number 13 is similar to 12. It's just written in a different way. This is still division. So I'm going to rewrite it this way. X squared minus 10x plus 21. I'm just going to write it with the division symbol because for some people, that is easier to see. All right, we need to do our keep, change, flip. Keep the first fraction. I'm going to factor as I go. This will be x minus 7, x minus 3, over x plus 2. Now I'm going to change the sign and factor. The denominator here becomes the numerator, x plus 7. And the factored form of the numerator will be x plus 7, x minus 3. I can cancel. X plus 7s go away. X minus 3s go away. And it looks like all I'm left with is x minus 7 over x plus 2. That's as simplified as you get. I can't cancel the x's. That's your answer. All right, let's finish with our favorite, the complex fractions. Oh, those look messy, but we're going to find a least common denominator, at least like a common denominator between everything. I have 8, 4x, 2x, and 4. Now, when I find these common denominators, I want to find something that when I multiply it by every denominator, every fraction, every denominator will go away. So if I chose 8, like if I just multiplied by 8, that wouldn't cancel with the x. So I need a number that 2, 4, and 8 all go into. That'll be 8. Since some of these denominators have an x, I also have to include x as the common denominator. Now I'm going to multiply every fraction by 8x. Now technically you're multiplying by 8x over 1. That was tricky for some of us the first time, so I'm going to write it here. Times 8x over 1. Alright, now let's simplify. I'm going to rewrite this a little bit. When I multiply by 8x, there's 3 over 8. The 8's go away. So all you're left with there is x. X times 3 is 3x. I'm going to do this one step at a time. Now top right, the x's will cancel. 8 over 4 cancels to be 2 over 1. So plus 1 times 2, which is 2. Let's do the bottom left. The x's go away. 8 over 2 simplifies to be 4, and 4 times 7 is 28. The bottom right, the 4 and the 8 cancel to be 2x. 3 times 2x is plus 6x. I can't cancel until I factor. The numerator does not factor, but the denominator does. It looks like just a 2 can come out of the denominator as a GCF. So that'd be 14 plus 3x. And while it isn't factored, nothing cancels there. So that's actually your simplified form. Now we can look at number 15. I know that looks messy, but number 15 here. Let's try. I need to find a common denominator. I pick a number that 8, 2, 3, and 12 all go into. Right? 8 doesn't go into 12, 2 and 3 do. They all go into 24. So I'm going to need the number of my common denominator that I'm going to multiply by to simplify it, be 24. Some of them have x's, but one of these guys has an x squared. So I actually have to multiply by 24x squared. So let's do that. I'm going to multiply everything by 24x squared. Then we'll simplify one piece at a time. So let's start with the top left. The 24 and the 8 will cancel. The 8 goes away. That becomes 3x squared. 3x squared times 1 is 3x squared. Now the next part. The x, one of the x's goes away. The 2 and the 24 cancel to just be 12. So I have a 12x in the top right. Negative 1 times 12x is minus 12x. Bottom left. One of the x's goes away, so that cancels with the squared. 24 over 12 is 2. So that's a 2x that I have on the bottom left. 2x times 1 is 2x. Over here, the x squares go away, bottom right. 24 over 3 is 8. So I have minus 8. Let's simplify. In the numerator, 3x factors out. So you're left with x minus 4. In the denominator, 2 factors out, x minus 4. I can cross off the x minus 4. So my final answer is 3x over 2. Those are a little bit extra challenging. There are other ways to do it. If you're good with those methods, I'm going to leave it. If you would like to see a second method, I'm going to go back right now and do the second way to do this. So I'm going to erase that. That was the common denominator method. If that's too much for you, oops, thought I made a good circle. If that's too much for you, let's talk about the other way. The other way to do number 14 would be just to deal with the numerator first. Find a common denominator for the numerator and add those fractions together. So here, my common denominator for the numerator would be 8x. So I would have to multiply the left fraction by x over x. The second fraction by 2 over 2. That would get me 8x in the denominator of both. So what I would have is 3x over 8x plus 2 over 8x, which would equal 3x plus 2 over 8x. That's a start. Now the denominator here, I would have to find a common denominator between 2x and 4. Well, 2x and 4, that common denominator would be 4x. So the right fraction would need an x, the left fraction would need a 2. If I multiplied those, I'd get 14 over 4x plus 3x over 4x, which is 14 plus 3x, over 4x. Now this is like 12 and 13, which is division. You would keep the first fraction, 3x plus 2 over 8x, times the reciprocal of the second fraction. Let's see if we can factor first. Simplify here. The 4 and the 8, the x's here will cancel because these are all factored. These x's cancel, and the 4 cancels with that 2. So I would get a numerator of 3x plus 2 and 2 times 14 plus 3x. That's your final answer, and that is exactly what we got the first time. So if you like that way better, simplify the numerator, simplify the denominator, keep change flip with the division. Let's look at number 15. I'll do that one the same way. So if you like that better, I'll do 15 again. So, deal with the numerator first. Find a common denominator between 8 and 2x. That would be 8x. So again, the left fraction needs an x. The right fraction needs a 4. When I simplify that, I would get x over 8x minus 4 over 8x. That simplified fraction will be x minus 4 over 8x. That's the new numerator. The denominator here, 12x and 3x squared. Well, I can have a 12. I think I need a 12x squared to work here. So I would just need to multiply the left fraction by x and the right fraction by 4. All right, the left one is x over 12x squared minus 4 over 12x squared, which simplifies to be x minus 4 over 12x squared. And that looks a little bit better. Back to 12 and 13 here. When I'm dividing fractions, I keep the first one, change to multiplication, and flip the second one. You can see the x minus 4's go away, so that gives me 12x squared over 8x. Well, now look, the x's cancel. I'm left with one of those. So I have an x in the numerator, 12 over 8, 4 goes into both, 3 over 2. That was the answer before as well. So that's the alternate way to do questions 14 and 15. If you have other questions, ask your teacher, check the key, look back at your old tests or quizzes.